In this session, we'll see how to interact between the script file and the Simulink file. So first we'll open the Simulink, which you can open using Simulink syntax in command window or directly by that red button. And then we'll create a model file. And we'll just, for time being, we'll choose a constant value to be displayed. So we'll go to Sinks and we'll use display to block. And then we'll connect it. And we'll assign that constant as, let's say, a variable A. So we'll go to that block, double click it, and press enter, and we'll assign it as a variable A. So when we run it, so the work directory is such that it will first check the workspace and then will come to the Simulink page and then it executes it. So let's make it parallel so that it will be easy to appreciate what's happening. So here we'll pass on a variable A with some random value, let's say 546, and we'll enter it, and so this value gets added in workspace, and now when we simulate it, it grabs the value from workspace and displays it. So it's the simplest way, if you call that number or if you define a variable in script or command window, it can be directly taken to Simulink. Now let's try the reverse process. From Simulink, we want to export a variable. So it's simple again. If you see, if you simulate right now, you will have some structures file. So to avoid that structures file, we'll just make our own. So we'll go to first, let's say, a sinusoid. And then we'll choose a scope. So we'll go to sources and we'll choose a sinusoidal signal. And then we'll go to commonly used block and choose a scope. It's not that we can export only the graphs, but graph will serve as a good part or a good data set to take it in the command space or command workspace. So you can directly search scope as well. There we go, and then we'll connect it. And let's simulate it directly. So we have default of 1, so we'll have a sinusoidal of amplitude 1 and a frequency of 1. So we want to export this data set to the command window or to the script file. So how to do it? So we have that T out, which is a structure file. When you double click it, you will have various signals inside, but we want directly that variable to come in workspace. So we'll go to again Sinks and we'll choose to workspace, that is sim out. We'll directly collect to the signal flow which we want to send, and we'll define this as, let's say, Y. One thing most of students or most of us people do is they define this as struct. So it's of no use right now because we'll be focusing on array, which is a direct calling in which we can directly call from the workspace, and we can simulate it. So we want x and y, x and t axis. We have send y axis, but how about t axis? So it will be coming from the internal clock. So we'll go to sources and we'll choose clock, and we'll send the same parallel data to y into a variable t. That is nothing but our time. So we'll just connect it to clock and we'll define that as a variable t. And again, it's in array format. So we can directly simulate it, and as we execute, just concentrate on the workspace. We'll directly have that variables coming out, t and y. So we have equal spaced arrays. So let's plot it. First clear the screen and then plot. We have seen how to plot, so we'll write plot. Plot it's a function, so round bracket, and inside it will be independent variable, comma dependent variable. So t, comma y. And as we execute it, we have the same wave shape as we had in a scope. There we go. So we have seen how to input to a Simulink file and how to take it from a Simulink file into command space, or rather in a script file. So we can morph and we can save it in our own format. So using this idea, we can make it a bit more complex or a bit more interesting. So let's try defining it as a variable. Like amplitude, we are defining as a variable VM. So we know the flow diagram. Before executing that, a workspace should contain a variable VM with some value. So let's define that to 10. And if we simulate this and call the plot command, so it should give a sinusoid of amplitude 10. So let's check. There we go. So we have the answer. So all the process which we have done right now, we'll just append it into some script file. So it will become like it's one of the best way to apprehend or to append two different formats, like script file and the Simulink. So let's get started with script editor. So we'll write or we'll perform the same thing which we did right now. So we'll start with CLC and clear all. So it clears the workspace, and then we'll assign variables which we have used, which we want to use. So we'll be writing VM as 10, and there is a function called as sim, S-I-M, to simulate or to directly simulate our Simulink model. But before that, we'll have to save our file. So we know how to define a function. So we'll write sim and round bracket. But before that, we'll have to save it because it takes input arguments as that file's name. So we'll just save this file. Let's say test1. So we have a file name test1, a model name test1. So let's call our sim function, and inside we'll write test1 with no extension as such, because sim refers specially to .mdl file. So as we execute it, we have our answer. So y and t will get produced after that fourth line. So in sixth or the subsequent lines, we can use the command plot. So it gives the plot. It's interesting to note in our script file, we haven't used t and y, but by the exchanges between the workspace, script, and the Simulink, we can achieve our desire.